Hi everyone, Part 6, Interpreting Graphs of Linear Functions. Consider the following graphs that show the temperature, T degrees Celsius, as a function of time, T hours, for two separate locations. Okay, so the temperature in location A. So if we have a look at this graph, okay, the point where the graph intersects the horizontal axis has the coordinates 4, 0. Okay, so that is called a horizontal intercept. So the horizontal intercept is 4. This point of intersection represents the time after 4 hours when the temperature is 0 degrees Celsius. Okay? The point where the graph intersects the vertical axes is 0, -5. So that's right here. So where it touches the vertical axes. The vertical intercept is -5. This point of intersection represents the initial temperature -5 degrees Celsius. So at time 0, okay, when we started counting time, okay, the temperature was -5. The domain here is between 0 and 12. Okay, so we started off at 0 and we went all the way up to 12. So that's the domain. The range is -5, so we start at -5 degrees Celsius and we went up to 10 degrees Celsius. So that's the range. The rate of change, okay, is we went up 5 degrees and it took us 4 hours to do so. So 5 degrees in 4 hours, so that is 1.25 degrees Celsius per hour. Okay, the rate of change is positive because the temperature is increasing over time. Perfect. So we learned a whole bunch of new words there. Horizontal intercept, vertical intercept. Okay, rate of change was positive, so that was a good one. Okay, now if we look at scenario 2, location B, okay, so we have a horizontal intercept of +5. Okay, so the horizontal intercept is 5. This is the point of intersection, represents the time. So 5 hours when the temperature is 0 degrees Celsius. Okay, the vertical intercept is 0, 10. Okay, so that means when I started counting for location B, the initial temperature was 10 degrees. Okay, awesome. The vertical intercept is 10. The point of intersection represents the initial temperature, 10 degrees. Okay, the domain for this one is 0 to 10. So we start counting at 0 hours and we stop counting after 10 hours. Okay, the range, on the other hand, that's the vertical stuff. So we start at 10 degrees Celsius and we go to -10 degrees Celsius. So the range is from -10 to +10. Now, not that you have to do it this way, but the convention is to always have the smallest number and then the biggest. You can go 10 is less than or equal to t, which is greater than or equal to -10. That does work, we just don't do it very often. So it's usually we start with the small number and go to the big one. Okay, the rate of change here. So we went down 10 degrees Celsius in 5 hours. So that gives us a rate of change of -2 degrees Celsius per hour. And the rate of change here is negative because the temperature is decreasing over time. Awesome. Okay, next page. Example 1. Determining the intercepts, domain, and range of a graph of a linear function. Okay, so this graph shows the height of a burning candle, or how the height of a burning candle changes with time. Okay, so A says, write the coordinates of the points where the graph intersects both axes, determine the vertical and horizontal intercepts, okay, and describe what these points of intersection mean. Okay, so let's see, the vertical intercept happens at, okay, each thing is 2, so 2, 4, 6, 8, 10. Okay, so the vertical intercept happens at 0, 10. So at time 0, it means my height is 10 centimeters. So time 0, my height is 10 centimeters. So this is the initial height of the candle. Okay, and that makes sense. Okay, so the height was 10 centimeters at time 0. Okay, the horizontal asymptote, okay, that is the point 45 and 0. So the time is 45 and the height is 0. What that represents, okay, so that is how long it takes for the candle to burn down. This is how long it takes the candle to burn down. Awesome. Okay, so that is all we need for part A. Then part B says, what is the domain and range of this function? Okay, so the domain, okay, so that is all the horizontal stuff. So the domain is all the times such that, okay, so we are bigger than 0, but we are smaller than 45. Okay, inside that, it's continuous data, so t is an element of the real numbers. Okay, then of course the range. Okay, the range is a height. So all the heights, okay, well, our smallest height is 0, and our biggest height was 10. So at time 0, our height was 10. Okay, and then h is also an element of the reals, because this is continuous. At any given time, I will have a certain height. And yeah, so continuous data, h is an element of the reals. Okay, so that is that one. Okay, example 2. Sketching a graph of a linear function in function notation. Okay, so sketch the graph of f of x equals 4x minus 3 by finding both intercepts and one other point. Now remember, f of x is just y. So 4x minus 3. So we can just do that. Okay, now remember, to be a y-intercept, I have to cross this line. Y-intercept. Now if you look at that, a y-intercept will always happen when x is 0. So look at this. That's the point 0, 1. This is the point 0, 2. This is the point 0, 3. So all the y-intercepts happen when x is 0. So watch what I do, because it just kind of makes it handy. So when you want a y-intercept, see what I do is put x is 0 just underneath, just to remind yourself of what's going on. So then we just put in 0 into the x for that equation. So y equals 4 times 0 minus 3. So that, of course, is 0. So y equals negative 3. So when x is 0, y is negative 3. So we put that on the graph. When x is 0, y is 1 to negative 3. Okay, so we can write that as an ordered pair if we really want, or a coordinate pair. So 0, negative 3. Now, of course, when we want an x-intercept, that is when the y value equals 0. Okay, so then we just go back to our formula and we put y is 0. So 0 equals 4x minus 3. So now we have a little bit of algebra to do. So plus 3, so 3 equals 4x, divided by 4, and x equals 3/4 or 0.75. So when y is 0, x is 3/4 or 0.75. That's pretty close to there. Okay, and we're also supposed to do one other point, it asked. So because we are the intercepts are when x equals 0 or y equals 0, now I can just pick anything, and it's always easier to pick the independent variable. So I'm going to pick an x, and you know what? I'm going to pick when x equals 1, because that's easy. Okay, so when x equals 1, so y equals 4 times 1 minus 3. So 4 times 1 is 4, 4 minus 3 is 1, so that's going to be y equals 1. So when x equals 1, y equals 1, okay, and that's this point right there. And if you have a look, if you draw these, those kind of line up. So we make a linear function, and there you have it. Okay, so we had a y-intercept of negative 3, an x-intercept of 3/4, or 0.75, and we could draw our graph like that. Okay, Next page. Okay. So, example 3. Okay, sketching a graph of a linear function in function notation. So we're doing another one of these. Okay, so which graph has a rate of change of -5 and a vertical intercept of 100? Justify your answer. Okay, so I need a rate of change of -5 and a vertical intercept of 100. So vertical intercept is this guy, so 100, 100. So they both have that. They both have a vertical intercept of 100. Okay, now, a negative rate of change, though. See, that means the numbers are getting smaller over time. Okay, so this one has the negative rate of change. This one has a positive rate of change. Okay, so because we're only presented with the two choices, it has to be graph A. But we should check a rate of change of -5. So a rate of change, okay, so we're going down 100, and it takes us 20 minutes to do that. -100 divided by 20 is -5. So really this does have the rate of change of -5. Perfect. Okay, let's have a look at example 4a. So this graph shows the cost of publishing a school yearbook for College Louis Riel in Winnipeg. So the cost of publishing a yearbook. Okay, so we have costs, we have number of yearbooks. Okay, the budget for publishing costs is $4,200, $4,200. What is the maximum number of books that can be printed? Okay, so there's a couple of ways to do this. So we are going to figure this out graphically first. So even though the points are not joined, we're going to dot them here. Okay, so $4,200. So this is 35, 40, so this is 45. So 42 is about there. So if I just make a dotted line, so 42, see it graphs or hits the graph right there, and then we just dot down. Again, using a ruler is a lot better. Okay, so that's 150, so this grid line is 175, and it looks like we're a little bit higher than that, so like 180, 185, okay, around there, so 180-ish books. Now, again, ish is never a good word in a math class, okay, but that's as close as we can get using a graph like this. So 180, 185, 109, like, well, 190 is probably, no, you can get closer than that. Okay, but 180, 190, 85 books, that's close. Now, let's do this better. See, here, the intercept is, here, let's just erase all of this. Okay, so the intercept is $500. Okay, so the cost is $500 plus. Now look, the rate of change, let's see, is, so 500, so 1,000, so, okay. So we go up $1,000 from 500 to 1,500. So we go up $1,000, and we have 50 books. So our rate of change is 1,000 over 50. So if we figure out what that is, so 1,000 divided by 50, so of course that is $20. So this is 20, and then I guess we'll call it N for number of yearbooks. So that's the formula for our scenario here. Okay, we have a flat rate of $500 and then $20 per book. So if we know that we have a budget of $4,200, I can substitute $4,200 in for my cost. So 500 plus 20n, and we can solve this algebra equation. So minus 500, okay, so that is 3,700 equals 20n, divided by 20, and n equals 185 books. Okay, so we said 180-ish, so we were close reading it off the graph, just not really, like not exact. So if we use the formula, now we can figure out exactly how many. So we can afford 185 books. Perfect. Okay, and then the last example. Okay, this graph shows the total cost for a house call by an electrician for up to 6 hours work. Okay, so the electrician, he shows up, okay, and he works for 6 hours. Okay, the electrician charges $190 to complete a job. Okay, for how many hours did she work? So 190, let's see, so 60. Okay, so 180 is here. So 190 is about there-ish. Okay, and we scroll down. Okay, so that looks like it's 2 hours, 3 hours. So 3 and a bit, 3 and a quarter hours maybe. So that's pretty close for the graph that we have. But again, that's not super accurate. So let's try making the equation again. So the cost, so this is where we use the vertical intercept. So the cost for no time is $60. That means the electrician charges $60 just for showing up, and then so much per hour after. So if we look at this, okay, we don't want to just go up by 60 because that's not a nice point. Like, let's go up to the next perfect grid point, which just happens to be right here. So we go up 60, so 120. So $120 for 1, 2, 3 hours of work. So that's our rate of change. So 120 divided by 3 is $40 per hour. So that's how much we're charging, or she's charging. So we have a flat rate of $60 plus $40 per hour. So 40 H's. Okay? So we charged, or the lady charged $190, and we want to know how much time she worked. Okay, so we just do algebra here. So minus 60, so 130. Okay, equals 40H divided by 40 divided by 40. So 130 divided by 40. Okay, that works out to the hours worked, or the time works out to 3.25 hours. Okay, so 3 and a quarter, that was pretty accurate from this graph. So either way, we got 3 and a quarter hours, or 3.25 hours. Okay, so that is it for this section. Okay, so this is section 5.7 in your textbook, starting on page 319. Please do those questions. That is it for chapter 5. So you have a formative assessment, so a review of all the stuff from chapter 5. Then you have a summative assignment, that's the curriculum review. And then you have a chapter 5 quiz. So good luck on all your assessments coming up, and we'll see you next chapter.